Hello, my name is Abel Tung, and I'll be solving homework assignment number 2, problem 10, which read a standing wave on a 1 meter long string that is fixed at both ends are seen at successive frequency of 36 Hz and 48 Hz. So what is the fundamental frequency and the wave speed? And we need to draw the standing wave pattern when the string is oscillating at 48 Hz. So in order to solve this question, we need to know what we're solving for, which is the fundamental frequency and the wave speed. And we know what, and is the first thing first, we need to recall what we know so far, which is the length of the string, which is 1 meter, and the two frequencies that would produce a standing wave, which is 36 and 48 Hz. To note is that both of these are successive frequency, which means that there is no frequency between these two that will produce a standing wave. So let's get the equation for a standing wave, which is the frequency of m, of harmonic m, is equal to m times the velocity of the wave divided by 2 times the length of the string. With this equation, we could plug in what we know so far for these two frequencies to get two equations. First, we have 36 Hz is equal to m of an unknown m times the velocity divided by 2 times 1 meter or 2 meters. For 48 Hz, we know that since these two frequencies are successive, that means that for 48 is m plus 1. So we could write down, instead of m of n, we could just write m plus 1. To get 48 Hz is equal to m plus 1, parentheses, times velocity divided by 2 meters. And we could distribute this number to get m times velocity divided by 2 meters plus velocity divided by 2 meters. If you notice, m times velocity divided by 2 meters is exactly the same as this equation, which is 36 Hz. So we could substitute this to get 48 Hz is equal to 36 Hz plus velocity divided by 2 meters. And from this, we could easily solve velocity, which is equal to 24 meters per second. And now we know the standing wave velocity, we could easily find the fundamental frequency, since, as we see, we just simply plug in the velocity and length and make m is equal to 1. And with this, we will get a fundamental frequency of 12 Hz. So therefore, we know the fundamental frequency is 12 Hz, and the wave speed is 24 meters per second. So now we solve for A. So now, in order to draw B, we first need to divide. First, we need to know what is the harmonic sequence at 48 Hz. To do this, we divide by 48, divide by 12 to get a number of 4. So what does 4 means? 4 means that we're going to get 4 antinodes and 5 nodes. And antinodes is basically the area of the wave of a standing wave that oscillates the greatest, and a node is the point where it doesn't oscillate, which is basically equivalent of this diagram. As we see, these 4 points are the antinodes, and these 5 points are the nodes of the graph. And with this, we have solved question number 10 at homework assignment 2. I hope you have a good day. Goodbye.